Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve first two questions from Probability and Statistics paper 53. And these particular two questions belong to paper 9709/53 for the session October-November 24. Let's read the question. Question number 1 says 30% of the residents of Winfield own an electric car. Three residents are chosen at random. Find the probability that either all three own an electric car or none of them owns an electric car. So, the question discloses the total number of residents. Look at this, total number of residents are 3. And probability of individual experiment is 0.3 or 30%. That means N and P are given. If the total number of experiment as well as the individual probability given, that means it's a binomial distribution. So let us solve the question applying binomial distribution formula. X belongs to binomial distribution. You know, the parameters for binomial distribution is nothing but NP. N is 3 and individual probability is 0.30. 0.30. So our N is 3 and P is equal to 0.30, whereas our Q is equal to zero point 0.7. That means 1 minus probability, that means having no car, the probability of having no car is 0.70 individually. Well, they have told that all three owns, okay, either all three own an electric and all three. So probability is equal to, let me write just beside this, okay, all three. So 3 out of 3 own a car. So probability of having car for each resident is 0.30. How many times? 3 times. And there is no resident who doesn't have a car. So probability of having no car is 0%. Or they have told or none of them. 3 choose none. Out of 3, none of them has a car. So 0.3 raised to 0. Nobody has a car, so probability is 0.3 raised to 0, and 0.7, that means none of them has a car. How many of such people? 3 people. Then if we simplify this, 3 choose 3. If we choose select 3 people out of 3, it's nothing but 1. So 1 into zero point 0.3, how many times? 3 times. That means 0.03 cube means 27. Plus 7 raised to 0 is 1, so unnecessary to be written. And 3C 0, that means if we select no people from 3, only there is one way. So 1 into 0.3 raised to 0 means again 1. So 0.7 raised to 3 times means 0.3343 it is. So our probability is going to be, if we add up 27 to 43, it is going to be 70. So 0.370 is the answer to the first part of this question. Then the immediate next question says a random of 125 residents of Winfield is selected. Use a suitable approximation to find the probability that more than 45 of these residents own an electric car. Okay, the clue word of this question is approximation. Approximation discloses that the question is given in binomial distribution, which is to be converted to a normal distribution. Well, and the parameters for binomial distribution is nothing but NP. We have already written here N as well as P. Okay. So let us start our solution. First of all, it is in a binomial distribution. Let us write in binomial distribution. X belongs to binomial distribution and whose parameters are n and p. N is total number of experiment, which is 125, and p is individual probability. We know that individual probability is zero point 0.3. Probability of each experiment is 0.30. Then this distribution should be converted to a normal distribution. So for normal distributions, the parameters are mean as well as variance. Mean is the product of n and p. If we multiply n and p, 125 3, it is 37.5. 37.5. And the other parameter is variance. Variance is npq. So np is 37.5 and q is zero point 0.7. Now we have written in the previous question, our q is n is 3, p is zero point 0.3, and q is zero point 0.7. Here n was 3, but it doesn't mean that everywhere the number of total experiment will be same. This is only for part A, but p and q will remain same. Okay, so if we multiply 37.5 by zero point 0.7, it is going to be 26.25. 26.25. Okay, this is our variance. Well, then they have told to find the probability that more than 45. Okay, let us write probability of more than x is more than 45 people. Well, at this point we should not forget to apply the concept of the continuity correction. Look at this, we are converting the binomial distribution into a normal distribution, whereas binomial distribution is applicable for discrete random variable, but the normal distribution is applicable for continuous random variable. So we will have to apply the concept of the continuity correction. So more than 45 means it will be 45.5. Okay, so please don't forget to apply the continuity correction concept. Then we are going to standardize this score. If we standardize this score, it is going to be probability of z greater than 45.5 minus our mean value is 37.5, 37.5 over standard deviation. Standard deviation is nothing but the square root of the variance. Variance was 26.2. So if we simplify this, probability of z score is definitely positive because positive number is greater. So it is 45 minus 37, it's 8 over square root over 26.2. Let us use our calculator. 8 over square root of, so let us write z is greater than 1.561. After that we will draw the normal distribution graph. Okay, this is what the normal distribution graph is, and the mean line is 0. As the z score is positive, it may be over here. Okay, 1 point, it has 0, and probability of the left part is zero point 0.5, and our z score is 1.5 lying on the right side. So z is greater than 1.561. So our probability is actually this portion, this tiny portion. Okay, So how can we find this tiny portion from this graph? It's very simple. From whole of the graph, look at this, from whole of the graph, if we subtract the left part, we can find the smaller part lying on the right side. And you may ask, why should we do so? Because the probability given in the probability distribution table, none of the probability is less than zero point 0.5. So probability given in the probability distribution table starts from zero point 0.5 and more than zero point 0.5. So always we find the greater probability for corresponding z-score. And remember, the graph is symmetrical. As the normal distribution graph is symmetrical, so it's all the same for the z-score. The difference is in symbol, whether it is positive or negative. As the z-score is same, it's on the right side, it's positive, so we require the probability rather than the smaller part. Will find the greater part. Then if we subtract this greater part from the small whole, then we'll find the smaller part. That means our z-score probability is going to be 1 minus from whole of this. If we subtract the left part, probability is z less than 1.561. So we will just subtract the corresponding probability which is lying on the left side from whole of the probability. Then we will get this black, tiny black part as our probability. Okay, I think you have understood. Because none of the probability given in the probability distribution table is less than zero point 0.5, it's always greater than zero point 0.5. So we will always find the greater probability, not the smaller one. And then if we subtract the greater probability from whole of this, we'll find the smaller region. So let us find the corresponding probability of this z-score 1.561. Okay, 1.561. Let us see our probability distribution table. Okay. Yes, from here our z-score was 1 point. Well, our z-score was, let me zoom it out so that you can see better. Our z-score was 1.6.1, 1.6, 1.561, 1.561. So let us encircle 1.5. Here is our 1.5. Okay, 1.5 is over here. Then 1.5, then 6, as well as this is the first column, 6, then 1 is over here. Okay, so row is this one, 1.5, then 6 is over here. After that it is 0.9406. Then we will add up this one for the last digit. This one should be added. Okay, so if we add up 0.9406 to 1, it is going to be 0.9407. So our corresponding probability, look, all the probabilities have been started from 0.500. So always you will choose the greater probability for the corresponding z-score. Well, so our probability of that region is 0.9407. 0.9407. Let us write this. Point 1 minus equal to 1 minus 0.9407. And if we do subtraction, we will get 0.505, sorry, 0.0593, 0.0593 is the result if we round it up to three significant figures. Okay, I think you have understood because I tried to explain every tiny part lying in this solution. Okay, so please don't get confused with this figure. If we are to find the tiny part of the normal distribution table, always we will find the greater part, and if we subtract the greater part from whole of the probability means 1, then we will get the tiny part, because none of the probability given in the probability distribution table for any corresponding z score is less than zero point 0.5, so it is always greater than zero point 0.5. So please choose the greater part between the two parts of the probability distribution table graph. So let us see question number 2. The next question says, it is on this page. Okay. A red fair six-sided dice has faces labeled 111, 222. A blue fair six-sided dice has faces labeled 112233. Both dice are thrown. The random variable x is the product of the scores on the two dice. Draw up the probability distribution table for x. Well, so both of the dice has been thrown. Okay, where is it? Both dice are thrown and x is the product. Well, so first of all we'll have to draw the scenario. 1 1 2 3 4 5 6. Okay, then 2 3 4 5 as well as 6. Okay, then 1 2 3 4 5 6. Okay, this is our scenario. Then the labels faces on dice 1, I mean red dice. Okay, red dice is 1, faces are 1 1 1 and 2 2 as well as 2. Okay, then for the second dice, this we may write here dice 1. Okay, these are the faces of dice 1, and on the left side we may write for dice 2. Dice, dice 2, dice 2, or dice blue dice, whatever you tell. For dice 2, the faces are what? 1 1 2 2 and 3 3. Okay, just let me try to. Yes, then the faces are for the blue dice are 1 1 1 1 1 1 2 2, then 3 as well as 3. Okay, so if, and look at this, our variable is the product of the scores, product of the score, product of the score. So product means multiplication. So let us do multiplication. If we multiply the red dice, the faces of the red dice by 1, it is all the same. So 1 1 1 and triple 2. Okay, triple 1 triple 2, then by 1 again. So is the second one, triple 1 triple 2. If we multiply by 1, then we are going to multiply by 2, so it is getting double, triple 2 and triple 4, triple 4. After that, so is the next one, immediate next probabilities scores are also so, triple 2 and triple 4. Then by 3 if we multiply, it is going to be triple 3 as well as triple 6, triple 6. So is the final one, final row is also triple 3 as well as triple 6. Now we will write the probability. Okay, for probability we will have to write, yes, So let us write probability when x is equal to when our score is 1, the minimum score is 1. Then probability when our score is 2. After that there comes probability of the score when x is 3. Then probability when our x is 4, as well as the last one is 6. So maximum score is 6. Probability when our score is 6, equal to equal to as well as equal to, and this one. Okay, let's see how many ones are there. Total there are 36 phases, we know. So out of these 36 phases, how many ones are there? There are only 6 ones. Look at this, first 6 are 1, so it will be 6 over 36 because total number of score is 36. So it can be done later on. After that, how many twos are there? Again, there are 6, as well as, look at this, these are the twos. For twos we may, okay, let us use the different thing. So these 3, this 6, as well as this 6. So total the score, when the score is 2, our total probability is going to be 12 over 2. So it is going to be 12 over 2. Let us write just a little below. So it is 12 over 36. 12 over 36. Then for the third probability, it is going to be, it's all the same. Look at this, it's 3. How many threes are there? 6 threes. Here are the threes. There are 6 threes. So it is 6 over 36. Then how many fours are there? Again there are 6 fours. So 6 out of 36. Finally, how many sixes are there? Again there are 6 sixes. So it is 6 out of 36. Now if we divide 6 by 36, our probability is going to be 0.167. And if we divide 12 by 36, it is going to be 0.333 because this is 1/3. After that, there is the rest of them are as same as the first probability. So it's all the same. 6 over 36 means 0.167. So is the next one 0.167, as well as the final one 0.167. Okay, now we will write the probability distribution table. So let me draw the table first of all. I think I can write just right side of the writing is over here. Sorry. Okay, then there are total 5 probabilities. So first one is x, and second row is for x equal to x, means score. Let it be written with lowercase x. So 1, 2, 3, 4, as well as 6. Okay. So when our score is 1, 2, 3, 4, as well as 6. So what are the probabilities? Let us see the probability. Except the second probability, rest of them are same. Look at this. Here all of them are 0.167 except the second one. So we just write here the second one is going to be 0.333. Rest of them are 0.167. Okay. So first one is 0.167 if we round it up to three significant figures. Second one was just exceptional. It was 0.33 as well as 3. And rest of them are as same as the first one, 0.167, 0.167 and again 0.167. So that is our probability distribution table. If you wish, you can write just above this probability distribution table, probability distribution table, probability distribution table, distribution table. Okay, so that's all about the solution to the first part of the second question. Okay, this is how we can write our solution. Okay, yes, that's all of the solution, whole of the solution. Then let's read the next question. Immediate next question is find ex. Ex means find the mean, and you know the mean is equal to probability into score. I mean x into probability of each one. Sum of the x and px. I mean probability will be multiplied with each of the score. So we can write here ex equal to, for the second question, let us start from here with a different ink. So Ex equal to Ex. Ex means expected value or mean, whatever you tell. Ex is sum of x into, this multiplication symbol is not necessary, x into probability of x equal to x. Okay. So let us write the result. If we multiply these, score was 1 and probability was 6 over 36. So 6 ones are 6. It is going to be 6 over 36. Then the second one, if we multiply, it is 2 and 12. 2 12s are 24. So 24 over 36 plus the third score is 3. If we multiply 3 by 6, it is going to be 18. 18 over 36. 36. Then the fourth one is, if we add up, I mean multiply 4 6s are 24. 24 over 36 plus the final one, 6 sixes are 36. So 36 over 36. Now if we add up all of this, numerator denominator is same in each case. If we add up the numerator first, let us see, the numerator is, final numerator is 36 and 24. So 36 plus 24, 60. 60 and first two are 24 and 6 30. 60 30 90. 90 plus 18, it's 108. 108. And if we divide 108 by 36, it is nothing but 3. So our expected value or mean is 3. And that's all about the solution to question number B of the question number 2. So that's all about the solution to both the first two questions. This is the first solution. If I zoom it out, it will look like this. Then for the second solution to the second question is this. Let me write over B. This is actually solution to question number B. Okay. I think you have understood my explanation, and may Allah bless us all with bountiful knowledges. Fi amanillah.